Hi, everyone, and welcome to the Data Services Office Hour. I am Michelle DiPalma, and I am here with Gaurav Midha to talk about multi-cloud.
Multicloud, multicloud GitOps with ODF.
Oh, wonderful, wonderful. Okay,
Yeah,
so do you want to give us an overview, or do you want to jump right into it? What would you like to do?
yeah, sure. So last time we had the session, we talked about multi-cloud GitOps, and in this session, I've clubbed ODF with the multi-cloud GitOps. So we'll be installing the ODF in the multi-cloud setup. We have different OpenShift clusters deployed in different clouds, and then using GitOps itself, we'll add ODF that can be used for storage as well as for infrastructure setup, such as registry, container registry, or logging or monitoring, where we can store the data in ODF using that setup.
Okay, so multiple clusters. You're going to use GitOps to install ODF, and then you're going to configure MCG after ODF is installed. Is that the basic idea?
Yeah. So what will happen is GitOps itself will configure the ODF in such a way that it can be used by the application using persistent volume claim or object but bucket claims.
Okay, perfect. All right, let's get started.
Okay, cool. So what I'll do is I'll share my screen and then I'll go over the setup first, and then there are 5 to 7 slides. I'll have to explain how this setup works, and then we'll jump to demo.
Okay. And all of this will be available to everyone. Can I put it in the description later?
Yes,
The okay,
yes,
perfect.
yes.
Thank you.
The code which I'm using, it's public GitHub repo.
Okay, perfect.
Let me share my screen.
Okay, let me know when you're sharing. I don't see anything yet.
Yeah, yeah. One second.
Okay, no worries, no worries.
Okay.
Okay, there you go. So I'm
So
gonna do this and I'll do this.
how it now?
Perfect.
Okay, cool. So we have three clouds which we are using today. First one is the AWS. In AWS, we have our hub cluster, and here we can see that three masters and three worker nodes are running, and it's basically OpenShift setup deployed in the AWS. That's our hub cluster,
Okay, so
and
pause.
then
So just for those who don't know, what do you mean when you say hub cluster?
yeah, so this is the same setup which I'm using from our last video, which we discussed on the multi-cloud GitOps. So we'll have to add the link of that particular video in this one
Sure.
so that everyone is aware of what I'm talking about. So it's
Okay.
basically a part two of what we already discussed in our last video.
Okay. So the hub cluster
Okay.
is sitting on top and controlling what's happening to the other clusters.
Yeah, so I'll come to that part. I'll just go over the review what we discussed last time. So first I'll go through what all is the ready, and then from there we'll take it forward.
Okay.
So this is our hub cluster. Hub cluster is the cluster which will basically manage our different Kubernetes or OpenShift cluster deployed in different clouds. So right now I'm deploying my hub cluster in AWS, and I have two managed clusters with me. First one is deployed in GCP, and this is the GCP cluster, which is deployed in Asia region. And
Okay.
there are three master and three worker nodes. This is one of the managed cluster. And I have another managed cluster which is deployed in Microsoft Azure. Same setup, three master and three worker nodes deployed in East US.
Truly multi-cloud. Yeah.
Yes. So we are using three clouds: AWS, Azure, and GCP for this setup. And I'll start with the presentation now. I just wanted to show that these are the three clouds which we are using.
Okay.
So last time we covered this slide deck, and I have added more slides to it regarding ODF. So I'll just start from this particular slide number 8.
Okay.
So here, last time what we did is we basically deployed the hub cluster. Hub cluster will have Red Hat ACM. Red Hat ACM is responsible for managing the different clusters which may be running in different clouds. And in addition to that, Red Hat ACM also deploys ArgoCD, and ArgoCD can be used to configure and deploy applications in different clouds. So this was the first setup. ArgoCD is basically a GitOps tool which is deployed using the OpenShift GitOps operator, and it will basically fetch the desired state of our cluster from the GitHub and applies it to our OpenShift cluster. Yeah.
Okay.
And now moving on to the next slide. So how does it look like in the UI for the ACM? So in the ACM, we will see similar thing. So here at the bottom, we have a local cluster. Local cluster is nothing but the hub cluster, and
Okay.
it's running AWS. And then we have two cluster, Azure cluster and the GCP cluster, and both can be supported. Like we can add multiple clusters. There's no like limit here on adding the cluster.
Okay.
Now this is the setup of the multi-cloud GitOps with different cluster. Before we jump to the ODF one, let's like add the Azure in our current hub cluster. So this is my hub cluster, which is running in the AWS one,
Mm-hmm.
and I have Red Hat ACM open in my console, and this is a hub cluster which I just showed that it's
I see, but
running in
it's not
AWS.
okay, so Azure, the one on Azure is not actually in ACM yet, and for
Yes,
those who don't know, ACM, Advanced Cluster Management, just so we're clear. Okay, so
yes,
you're gonna add it now. Oh, that's cool, so we'll see what that
yes.
process looks like.
So
Okay.
I'm going to add the Azure cluster here, and it may take like 9 to 10 minutes to basically set it up properly to make it available as managed cluster. So that's why like I'm doing that particular step right now.
Okay.
I already added the GCP cluster to ensure that we have a working demo in the video.
Thank you, I appreciate
So,
that.
you're welcome.
So are you adding
So
or are you importing? Like, I
importing,
saw okay, all right.
yeah. So let me just here is yeah. So this is the Azure cluster. I'm logging into the OpenShift cluster. So right now we have 65 projects, and we don't have OpenShift GitOps. We don't have Open Cluster Management add-on.
Okay.
That's like when it becomes managed cluster, it will show up here. So what I'm going to do is I'll basically click on import cluster in Red Hat ACM, and here I'll add the Azure cluster name, and I'll just use this particular tag. So this tag is pretty important. I'll show in my code like what this particular tag does to the cluster.
Okay.
So I'm just using cluster group is equal to Azure.
Okay.
So it will just give me the command which I can run in my terminal. So I've
I see.
copied the command and I'll just run it here. So it will basically create few resources, cluster it, and other things, which will ensure that this Azure cluster is able to communicate with the managed cluster,
Okay.
this hub cluster, sorry. So these are the resources which are getting created. It will
Okay.
take like 5 to 7 minutes to basically install all the application, create the storage cluster. So I'll go back to the PPT and then just move forward from there.
Okay.
And here under manage cluster, it right now it's just showing pending import. Once it's ready, it will be showing as ready, and then here we'll see the Microsoft Azure.
Awesome.
Cool.
So we'll check back on that later.
Yeah,
Okay.
yeah, 5 minutes. So now moving back to the PPT. So before we like jump into like Red Hat ODF. So what is Red Hat ODF? So ODF is OpenShift Data Foundation. It's a software-defined storage solution for the containers, and it basically provides a platform for data and storage needs. And what are the features of Red Hat ODF? So it basically provides a enterprise cluster data management for Kubernetes or OpenShift cluster. So we can basically store the objects, we can do data replication, we can do disaster recovery capabilities with ODF. And it also increases the developer productivity. It provides uh, data management capabilities with it, so that in, we can have a developer basically provision the storage on the fly by using or creating the persistent volume claim. And next feature is the consistent experience everywhere. So we can deploy ODF in multiple clouds, and without going into the details, developers can basically just use the same functionality and get the storage needs required for their application.
Hmm.
And next is the Red Hat ODF can be used for application as well as infrastructure. So we can use ODF for the container registry, for logging and metric storage as well. So it works for both the application as well as infrastructure. So we can create a container registry which is backed by the Red Hat ODF.
Okay, so a few questions. So ODF in the cloud and ODF on-prem pretty much look the same with just a few changes. Is that correct?
Yes, that's correct.
Okay. And upstream is Ceph for those who are Ceph experts. Okay. All right. Fantastic. Cool.
Cool. So moving to the next slide. So this is the Red Hat ODF architecture, and it's basically simplified architecture. So I'll just go over it quickly. So here in the middle, we have three operators. OCS operator is the meta operator, which basically installs Rookcef operator and Nuba operator. And Rookcef basically provide the backend services for file, block, and object data storage. And then we have Nuba operator. Nuba operator is mainly for MCG, so multi-cloud gateway service, which basically we can store the objects in multiple cloud. And then on the left side we have LSO. LSO is a local storage operator. It's mainly used for managing the storage provided by the local disks. So we have local disk, and if you want to manage those, we'll use LSO.
And we did a show using LSO. I think we've done one. I know we've done one with Daniel Parks, but possibly an older one with Annette Cluett as well. So awesome.
Yes.
Sorry, continue. Yeah.
No problem. And in the center, we have Ceph services. So Ceph services can basically pass the data into Nuba uh, for the object services, for the object storage. And they can also pass the Ceph services can also pass the data to the Kubernetes CSI plugin if container or VM is trying to access the uh, data directly.
Okay. So
And
in the
here,
case of sorry, you're just about to talk about my question. So the cloud object storage, when you're not on-prem, when you're in the cloud,
yes,
what's the default is to use what the cloud provider offers, or is that still the case, or how does that work on the ones you
yes.
have installed now? Okay.
For on-prem, we can use Ceph as the object store,
Okay.
and we will be able to use the rook Ceph operator and just use the Ceph as well, Ceph RGW, to access the storage as object store.
Okay.
And on the top we have container or VM, which can basically request the persistent volume claim or the object bucket claim. And once these requests are in there, then basically these operators will come into picture to create the required storage.
Okay.
So object PVC, RBD, CEFFS, and RGW request will be taken care by the Rook Ceph operator, and for object bucket claim, Nuba class, that will be taken care by the Nuba operator.
Okay. Understood.
Thank you. Now moving on to the next one. So this is how like it will look like. So here on the left side we have hub cluster where we have Red Hat ACM and other applications, and in addition to that we will be using ArgoCD to install Red Hat ODF. And same thing, ArgoCD can be used for managed clusters as well. So we can have like different settings for managed clusters. So let's say in my hub cluster, I just want to like deploy object store. So we can deploy the storage cluster as such that it deploys only for the object store. And
Okay.
if we want to use block devices in one of the managed cluster, we can configure the Red Hat ODF to just deploy the object store. So we can configure the settings in there. And if you want to control the replica, how many replicas shall be deployed, so that can setting can also be controlled. So we have like different settings that can be controlled for a particular cluster.
Okay, so if you wanted to take it down to just 2 replicas instead of 3, for instance, you can control all.
Yes.
Okay, awesome. Fantastic.
Yeah. So let's say in one cluster we just need 2 replicas. We can just change the setting for that particular cluster, and it will deploy only 2 replicas.
Okay.
Okay. So moving on to the next one. So here is how it will look like in the Red Hat ACM UI. So we have ODF deployed as an application. So ODF is deployed in the OpenShift storage namespaces. These are the clusters: Azure cluster, GCP cluster, and the local cluster. And the resource, it's basically like Git repo, which is getting deployed through the Argo CD. Okay. So moving to the next one. Now,
Okay.
yeah. So we what we are going to do is we are going to use Red Hat Quay. Red Hat Quay is basically the container registry which is highly available and distributed, and we'll be installing that with ODF as the backend, so we can store our container images in the Red Hat Quay.
Okay.
Some of the features of Red Hat Quay is it provides granular security management. We can control like who has access to our container, and we can track, and it automatically scan the images for vulnerabilities. Another feature is it's very fast and robust at any scale. So we can basically deploy multiple instances of Red Hat Quay across different data centers. And next feature is high velocity CI/CD. So we can basically use our CI tools. Oops, 1 second. Yeah.
There.
So we can
Thank
use our CI tools to build our Docker images, container images, and then just use to store those images and use the images again in our continuous deployments.
you.
It
Okay.
provides high velocity CI/CD.
Nice.
And another feature is automated installation and updates. So we can configure how frequently we can update the registry deployments with Quay operator.
Hmm.
Another nice feature is enterprise authentication and team-based access control. So we can integrate our existing registry with the identity providers, and we can manage the access from there. And last feature is where we can use Red Hat Quay with different OpenShift tools such as monitoring and alerting, as well as
So
OpenShift data
full
foundation.
integration. Okay, so full integration with OpenShift. That's nice. Okay.
Yes. Okay. So moving to the next one.
Okay.
So here in the last slide, we deployed Red Hat ODF in all the cluster, hub cluster, as well as managed cluster. And in the hub cluster, we are deploying Red Hat Quay, which will be backed by the Red Hat ODF, and we'll be able to like store and use our images from Red Hat Quay.
Okay.
So that's like one of the feature which will be provided by Red Hat ODF. We can use Red Hat ODF as the backend, and Quay can use ODF to store the images.
Okay.
Okay, cool. And before we jump onto demo, I'll just go through one of the application which we are using in this particular demo. And the name of the application is image tool. And so we it will be deployed as one of the container in the pods. And what it
Okay.
will do is it will request the persistent volume claim using the ceph class. And using this particular persistent volume claim, it will go to the rook ceph operator, and from there ceph services cephfs will be used to basically provide the storage. And this rook ceph operator will be deployed by the OCS operator, which is the meta operator which we already installed.
Okay.
Nice. So I'll just start the demo then. So here, so right now I'm in this GCP cluster. Here, like I already integrated GCP with the hub cluster. So I'll just show what all got deployed in the GCP cluster.
Okay. From the hub cluster. Okay. So I should see a GitOps project. Or okay. Oh, I see. You're going to go right into storage cluster. Awesome.
Yeah. Oh, okay. No, this one
All right.
is wrong. So,
No worries.
yeah. So right now it's showing in error, so I'll check what happened. But
Oh,
it got deployed properly earlier.
okay.
And now let's go to the, okay. So here in the project, the OpenShift storage was created, and then we have the OpenShift GitOps where ArgoCD is deployed, and
Okay.
then we have the image tool. Okay, so let me just get the pods for image tool. So not sure what happened to the GCP. So okay, that's okay. I'll check what happened to the GCP one. So
Okay.
let's move to Azure.
Okay.
Let's see
And
that.
feel free to troubleshoot now. Like that's part of it is it's useful for people to see you checking things. So by all means, no, it will be fun to see.
Yeah,
Okay. Are you on which one are you on now? Are you in Azure or are you
right now I'm on Azure.
okay.
Yeah. So in the Azure we have the OpenShift storage. So let's go to the, so the OpenShift storage is deployed here. And these are the pods which are deployed as part of the OpenShift data foundation.
Right.
And the storage cluster is, let's see the storage status of the storage cluster. Yeah, so it takes time. So is it usually takes 10 minutes to be in ready state,
Okay.
and then it will basically resolve to ready.
Okay.
That is expected behavior, because OpenShift cluster storage cluster takes at least 9 to 10 minutes. So I'll show it in the meanwhile. I'll show other functionality to you.
Okay.
And now moving on to the, yeah, so moving to the UI. So this is our hub cluster, ArgoCD.
Okay.
Yeah. So this is the hub cluster ArgoCD, which deploys the Quay registry
Hmm.
and ODF as well as image tool. So we'll look at the query registry. So I'm in the OpenShift console for the hub cluster, and I'm going to go to the routes for the query registry.
Okay.
So these are the routes, and I deployed the query registry in the Quay enterprise, and this is the registry. So I'll just click on this one. Yeah, see it. So I created one user also Quay admin, and right now I'm logged in as a Quay admin. So this is the internal registry which is backed by the uh, Red Hat
Right.
ODF.
Okay.
Yeah. So that's the Quay registry, and if I go back to my terminal and check the storage cluster in here. I'm right now I'm like in the hub cluster. Yeah, see here, like I deployed this setup almost like 4 hours ago, so it's
Right.
in ready state.
Okay.
And if I go and check the pods, that will also be like running properly. So these are the pods running. And if I go to the Quay Enterprise instance where my container registry is deployed, so these are the pods which are running for the Quay.
Okay.
And if I go and check the route, it will basically let's check the code.
Oh wait, you need a space. Yeah.
Yeah. So this was a registry which was deployed like 4 hours ago, and if I
Okay.
describe it, will show me that all the components are ready. It will basically show that these components are were deployed and these are like ready and healthy.
Nice. Okay.
Yeah. So
Okay. All the
that's about it.
details.
Yeah. Let
Okay.
me just check this one again. Yeah, see here, like earlier it was in error. Right now I'm in Azure one, and earlier it was in error state.
But now it's
And
progressing. Okay.
yeah, right now it's progressing. So it will take like 2 more minutes and then it should be in ready state.
Okay. So I guess it's setting up monitors, making sure all the
Yeah,
metadata is copied everywhere it needs to be, et cetera, et cetera. Okay. All
yes,
right.
yes.
Do you want to look at GCP?
Yeah, sure.
See what's
GCP,
going on.
like I will have to debug it. I'm not sure. Like,
Okay.
yeah, so here,
Okay.
like, that's also like in ready state right now.
Yeah. Okay. Perfect.
Oh, I think I got it now. So, right now, these both terminals are connected to like same OpenShift cluster. So let me like get the credential for the GCP. One second.
Oh, okay.
So yeah, so this is the GCP one, and if
Okay.
I go to the yeah, see like I deployed it 1 hour ago, so it's 57 minutes ago. It is
Right.
ready,
Okay. Okay.
and now if I check the like image tool, check the pods. So these are the like two routes for our image tool application,
Okay.
and let's open this application here. So see here, like I uploaded one this image in the GCP one when I was
Okay.
working earlier. So this is the image which is stored in GCP.
Okay.
And if I click on the delete, it's a Chrome issue. So right now it deleted the image, and if I click on choose and just upload, let's say upload another image of let's say ArgoCD, I will do it, and it will just upload the image. So this is the image which was uploaded recently, and if I click on the view, so it will
You
just
can.
show me the ArgoCD symbol.
Okay.
And the application, the Nginx application which we have, that's also like pointing to the same PVC. So if I go here, so that's another UI just pointing to the
Oh,
same
I
UI,
see.
same PVC.
Okay. So this PVC that image tool and Nginx are using are being supplied by ODF that was
Yes.
configured through GitOps. And then so the Quay registry on the hub
Mhm.
cluster, what
Yes.
images are you storing in that particular registry? Or was that just for display or is like image tool like what's coming out of this repository?
Sure. So right now, like I'm not storing anything. It's like I just wanted to show the installation part and how like ODF can be used for creating query and then storing the images. But I can
Okay.
like store the images here, and then managed clusters can basically access the images which are stored in the hub cluster in
Okay.
this container image repository.
Nice. Awesome.
Thank you. And now I'll just go to the code. Let me share my screen.
It's YAML time. Okay. As always with GitOps, right? It's kind of
So this is the repo multi-cloud GitOps, and here I'll just talk about the main files which I'm like using heavily. And here this is the file values hub.yaml, where we basically specify like all the resources which needs to be deployed in the hub cluster. That's why like it's mentioned as values dash hub.yaml. Okay. And in the hub cluster, so these are the key value pairs which are basically getting passed into the charts. So these are the charts which are basically like YAML files which are basically deployed in different clusters. I'll talk
okay.
about charts shortly. Before we go there, I'll just go through the values hub.yaml. So here we have defined like what all namespaces we need to create: open cluster management vault, config demo, OpenShift storage, local storage, image tool, Quay enterprise. So these all namespaces are the values which are getting passed into charts, and then those charts will be deployed through ArgoCD.
Okay.
And then we have subscription. Right now, from here I'm using the ACM and the Quay operator subscription, which are basically getting deployed. And these are the projects are related to the ArgoCD project, which are basically used for doing the deployments. And then we have the applications. So applications are the Argo applications. So this is the name of the application, this is the namespace project, where the uh, it's basically a terminology of the Argo CD, and path where like this particular application is defined. So it is defined under common slash ACM. So there's a folder common, and under ACM there are like templates. So using those particular templates, like ACM is getting deployed in the hub cluster.
Can I ask you a question?
Sure,
So,
sure.
and this is probably showing, I'm learning more and more about GitOps all the time. So maybe this is due to my lack of knowledge. But if you scroll up back to subscriptions, you would not subscribe to the ODF operator?
Yeah, sure. Good question. So what I've done is I have installed ODF as part of the application. So if I go to, let's say I go to Azure,
Mhm.
under ODF there are templates. In template I am basically using this particular operator
I
as
see. Okay.
subscription. So I've defined it in YAML.
Okay, and you just do it under the platform as an application as opposed to at the top. Okay.
Yes.
Okay, and
Yes.
what's the advantage of doing this way? Is it because you need to get more
So if
customization or like
yes, for more customization, if I have to like make more changes, then I'll just basically put it under the particular
I
uh,
see.
cluster folder.
Okay.
So
Okay.
yeah, I'll just show it shortly. Now going back to the values hub.yaml. So these are the subscription projects, applications. So ACM is getting deployed, Vault is getting deployed, Golang external, image tool, ODF. ODF is basically where it's coming from. So it's coming from charts, hub, ODF. So I've defined ODF in multiple places so that we can customize ODF for different cluster. So in our hub cluster, we are just using ODF for Quay, as our container registry is basically going to use ODF for storage. So
Mhm.
I use specific settings for that particular setup. So if I go in the storage, this is the YAML file of the storage cluster. So here I'm just using the multi-cloud gateway to store the
Okay, with the
data.
GPT. Okay, gotcha. Okay.
Yes, yes. So we can basically customize it more if we put it under the in the YAML files under the folder.
Okay.
And now going back to the values hub.yaml. So these are the applications, Quay, ODF, and then at the last we have defined as managed cluster groups. So initially when I started this demo, like I mentioned that this is the particular tag. We have to ensure that we remember this particular tag. So this tag is cluster group Azure. So I'm basically defining three cluster groups which will be treated as managed. First one is region one, second is the Azure, and third is the GCP one. So if
Okay.
I create or import any cluster with this particular tag, cluster group Azure, so it will basically deploy all the applications related to this particular tag.
Okay.
And here, like there are separate YAML files, values GCP, values Azure. So these are the files which will basically be deployed.
Okay. So then you can get specific to the platform if you need to. Okay.
Yes, yes. So I'm deploying ODF and image tool as part of the Azure.
Okay. Will you look at values global as well, just for comparison to see what? Okay.
So values global, like if we want to define any like anything which we want to pass to all the clusters, then we
Oh,
can
nice.
define.
Same
Right now,
password.
I'm
Okay.
just using it for storing the dummy passwords,
Okay.
but it can be used for global.
Nice.
Here, let me just show it to you. So I'm going to Quay and not here. Yeah, here. So not
So somewhere in here you say use a certain
yeah.
storage class. That one of the ones we created from ODF.
Yes,
Okay.
yes. So here, like query registry, it will automatically try to pick up the particular object class. It will create the object bucket claim, and then it will basically try to see like if it's able to create the object bucket claim, and if it does, then it will get
And
deployed
use
properly.
that. Okay. Okay. Nice. Mm.
And here under ODF, in under so this one I already showed you that how it can be configured. Yeah, I think
So
that's
I was just going to say, in the case of on-prem, for example, ODF, the storage class there would be whatever you've like the RGW kind of storage class, right?
Yes,
We're just
yes,
we're in AWS. So okay, all right, that makes sense.
yes.
Awesome.
Okay. Good. So moving back.
Okay, and we should. You want to check on Azure at some point?
Yeah.
Okay.
So Azure, is the Azure. So one second. So I'll have to just log in into the Azure one. And yeah, so it's ready now.
Okay.
And if I so these are like image tool is running, so we can just access the application here also.
All right. So this one's gonna. This is a. This is running in Azure. It's not the GCP one. We will not see the same image. It's completely separate. There's no
Okay.
replication or copying going on between the two. No snapshotting. I mean to say. So okay.
Yes.
Okay.
So it's brand new and it's different as compared to like this one
Okay.
because it's deployed in the Azure.
Okay.
Here, like it's easyopenShift.com. And if we like upload any image, let's say this one.
I was gonna after you show us this, I was gonna ask, can we have another look at the ArgoCD dashboard and and just maybe like show
Yes,
people how you if you wanted to if you were having an issue with the GitOps piece of this, how do you drill down into just the AWS part? How do you not AWS, how do you drill down into just the Azure part? Things like that. Like
yeah, sure.
that the dashboard has a lot, so I just thought maybe it might be useful.
Yeah, yeah, sure. So this is the Azure one. So I'm just logging into this one.
Okay, so each cluster is going to have its own GitOps,
ArgoCD.
Argo CD. If you're having an
Yes,
issue with it, you log into that dashboard on that cluster and troubleshoot
yes,
what's happening. Okay.
yes. In the meanwhile, yeah, it's good. It came up. Okay. Um, this is the Azure one,
Okay.
Microsoft. And so these are the applications which are deployed in here.
Nice.
OpenShift storage, namespace, ODF, image tool. Here we can like check the status of particular, like let's say if we want to check the status of ODF application, so we can just click on details.
Okay.
And here like in the live manifest is the manifest like which is deployed in the cluster,
Okay.
and we can check whether the status is healthy or not.
And if you'd
So
made a change to the you made a change to what's in Hub, what's in your ACM cluster, you would then
mm,
see that this is out of sync, right? It gets pushed down or okay.
yeah, sure. So
All right.
what will happen is like if we make any changes, it the change has to go inside the Git repo itself.
Right.
And what then from there it will basically pull the change automatically. Let's say if I deploy a version 2 of image tool, what will happen is it will aut- uh, ArgoCD automatically refreshes the state. So it will basically keep on checking every 3 minutes what is there in the Git repo and what's deployed in the OpenShift cluster. And if there is a mismatch, then it will show the status as out of sync here. And then there are options to basically like sync it or like automatically sync. We can that can be configured.
Okay. Oh, it's a fantastic. Awesome.
Thank you. Yeah.
Yeah. Really nice. And all of this is available in a public repo. I'll put the links in the description
Yes,
so that
yes,
people can pull this down and just modify as needed. Oh, wow. Really
yes.
nice.
And this is the dashboard for the GCP one. So I
Okay.
already opened it up. So just show it to you. It's the same. It will look like same multi-cloud GitOps GCP,
Right.
and same applications are deployed. GCP GitOps and other things.
Fantastic. All right. So is there any more you want to show? Anything, any gotchas, anything, need to consider? Anyone would have to think about? I saw that like in terms of your GitOps, I assume it's standard to have each cloud provider broken out into a different folder, that kind of, is that normal? That's not an ODF thing, right? That's just a normal infrastructure thing, taking
No,
advantage.
it's normal infrastructure, but
Okay.
the thing is, like, if we want to manage and configure different cluster groups, then we'll have to use the different let's say we have 7 clusters which are using the same configuration, so we can define a name here for those 7 cluster, and we can apply this particular tag to those 7 cluster,
Okay.
and then all those 7 clusters will basically be applied the same configuration.
Fantastic. Okay. And I assume the global stuff, in terms of order of operations, like all of the global stuff and common stuff gets applied first, and then the customized
Yes,
stuff comes after. Okay. That
yes,
makes sense.
yes,
Awesome.
that's right.
Wow. Okay. Well, if that was a wonderful demo, and all of the links that everyone needs will be provided, and hopefully we'll get some questions and we'll be able to answer them. But that was fantastic, and this is all available for people to use and modify for their own needs. Thank you so
Yes.
much, Gaurav. That was awesome. Thanks.
Thank,
Okay.
thank you,
All
Mr.
right. All right. Everyone, take care. Bye bye.
Yeah.
Thanks.